Hello, I'm Chris Athanas. I'm a KMP developer. Tech Sport's coming out Tuesday for that thing to closed up. And today I'm going to be reacting to and following along with Derek Martin from CodeOpinion.com. And we're going to be going over his top 5 patterns that you kind of need to know for doing back-end development for KMP using KTOR. And these patterns, I'm going to try and help to translate what he's talking about, because sometimes it's hard to understand what he's talking about, because he talks very back end technical, but his ideas are really sound, and I really like the graphics. So here we go.
Hey everybody, it's Derek Martin from CodeOpinion.com. If you're new to event-driven architecture, you're likely to run into some common problems that have some pretty established patterns for dealing with them. Here are 5 patterns and concepts that will help you with event-driven architecture. This video is brought to you by EventStoreDB, the stream database built from the ground up for event sourcing, CQRS, and event-driven microservices. For more on EventStoreDB, check out the link in the description. So the first pattern to talk about is the outbox pattern. And here's the problem it solves, is we have our application and we have our primary database. It could be a relational database, it could be a NoSQL database, doesn't really matter, but you have a primary database that you're making all your state changes to. Let's say the command or
So your client is going to be the iOS or Android application, or your web app or desktop, or any or mix and match. So they all can be considered the client, and it's the protocol here is a document or SQL or whatever, and then there's a database somewhere, and this is running on your KTOR server somewhere, and your message broker and a database usually somewhere else. That'll be on your KTOR server. For your MicroMonopoly operation, it's just going to be a modular monolith. Usually running on one instance until you get 10,000 users or something, then you can upgrade it. But you could probably upgrade it vertically before you start thinking about spitting off and services for micro monopolies. I don't think we're not going to really need to do that too much.
something that we're processing is placing an order. We're creating an order within our system. So we do that, but we need to publish an order placed event to our message broker. So we save our data, we publish to our message broker, and it all works. But what happens if we're unable to publish that message to the message broker? That means that we have state that we persisted, like placing an order, but we were unable to publish that event.
Like the server's down, like if you're using Redis right here, which I recommend using this KREDS from this guy, Crack the Code, where is it, KREDS? This is what I recommend using, the library for Kotlin for all these different queuing and PubSub and all that stuff. Just use Redis. It's makes your life so much easier.
Our system could be in a really inconsistent state if we have other parts of our system that need that event to consume it and be reactive to it. So the solution here is the outbox pattern. And what this means is we are going to save our document, our state, to our primary database, and the message, the event that we want to publish, to our primary database in a single transaction. So what that looks like is we're going to have our...
So basically it's just going to be like instead of having call someone directly, now you're talking to a receptionist who's going to write down the message. So if the guy that's supposed to doing the work went to lunch, the messages get through. That's the basic idea.
Our SQL document that we're going to persist to our database, and within the same transaction, we're also going to basically serialize the message that we want to publish to the message broker. But we're not publishing it to the message broker right away. We're just saving it in a separate table or separate document along with our state in the same transaction. So it's one atomic transaction that contains both the state change and the message. Then what we have is a separate publisher that's looking at the messages that needs to be published, and it's going ahead and publishing to the message broker. Once that succeeds, it goes back to the database and either deletes it or flags it as being published. Now, the caveat to all this is that makes sure that we're always going to publish a message at least once. But there is a scenario where when we try to mark that message as being published back to our database, if that fails for any reason, we're going to ultimately try to republish it, which we will, to our message broker, which means that we can be publishing messages more than once. But that leads to the next pattern. Creating idempotent consumers are a way of handling at least once delivery. And you'll hear that term often in messaging, which means that a consumer may receive a message more than once. So one way of doing this is when your consumer processes a message, it records the message ID, which is a part of the message, in relation to what other data it's saving, if it's making some other state transitions to its own database. So that means as it processes a message, it makes some state transition, does something with its database, it records that message ID. That way, when it comes time to, if for some reason that same message gets delivered and consumed to that consumer, that it can reach out to the database saying, have I processed this message already?
Yeah, so the whole idea of idempotency is like, if I say process this order ID number 6, and you get the message, and you get another thing that says process order ID number 6. Well, it's like you can go look at the database, and your local database for this service right here, to see if it's already been done or not before you process it. If you're gonna be if you know you're gonna be working in an async system, that may occur. So you just check first. Ooh, okay. Item potency. Okay, that's no big deal. I mean, usually these the message broker, the queue or the pub sub, whatever you want to use here, will usually handle that stuff. But it's not a big deal to check it already before you try it, knowing you have this system set up in this way. Yeah. Good to know.
If I have, then disregard, I don't need to process it again. So another way to implement an idempotent consumer is to use the inbox pattern, which as it sounds is the exact opposite of the outbox pattern. So what we're gonna do is instead of our message being
okay, so if you don't have, so it's just the same as the inbox outbox, like on a desk back in the old school when you had an office. Everyone's had their own desk. They had an inbox. They have an outbox. Someone would put an order or some sort of something to be working in your inbox. If you weren't at lunch or you're off that day, it would still get piled up into your inbox. And when you came into work, when that service comes up, when you come into work that day, and you get all the things are sitting there, they're not lost, they're not missing anywhere, and you take off each one, process it, and put it onto the outbox. Instead of passing it directly to somebody you put it in the outbox, and so the mail guy comes along and the stuff he's dropping off, he's picking up your stuff and sending it off onto the message broker. That's it. That's the idea. It's very technical language, but that's the basic idea.
Being consumed directly by our consumers. Instead, we're going to have an inbox in front of that. So we're going to consume a message and immediately store it within our inbox. And then we're going to acknowledge back to the message broker that we've received that message. So that way, if we receive that exact same message again, our inbox can just say, sure, disregard it, we don't need to do anything, and just acknowledge back to the broker that we've received it. From there, we can have a separate process where our consumer then picks those messages up from the inbox, and just like the outbox pattern, if we have any state transitions we need to do, we can do them within the same transaction to mark that we processed the message from the inbox and saved whatever state we needed to at that time as well.
Yeah, this is the employee right here. That's where he's doing all the work, and it takes it from his inbox. Ooh, inbox pattern. Ooh, it's like, okay, a lot of these things are just copying stuff we used to do in the office when you didn't have a computer doing this stuff. You didn't have a computer here. It was actually a person, like a receptionist, and she would like write down the message for you or take the order for you, and then pass along to the other person who's go to the shipping department, or whatever. That's all we're doing here. It's the same stuff. Just think about these as people. That's just a really easy way to. So this complex terminology, sophisticated terminology, it's very technical. You can just think of these as people. What can they do? They can answer a phone. They can send a message. They can, write down on a file sheet. They can put things into a database, read things from a database. That's a processor.
All within the same transaction. So the next thing to talk about is event choreography. So as this relates to the outbox pattern in idempotent consumers or an inbox, is that distributed transactions aren't happening because we're within a service-oriented architecture. So how do we deal with that when we have a long-running business process? And by long-running, I mean hundreds of milliseconds to days or weeks. So how does that work when we normally think about one transaction with one schema? If you have different services and they all have their different databases, how do we deal with that? So with event choreography, the way it works is we have our sales service, for example, here, and it's publishing an order placed event. From there, what we're going to have is billing is going to consume that event. And let's say billing at this point needs to charge our credit card, create an invoice of some sort. So let's say it does that based off that event, it reacts to that, and then it publishes an order build event. From there, our warehouse service may pick that up and realize, okay, I need to do something, a part of the workflow here. So it consumes the order build event. Let's say it needs to allocate product in the warehouse to be shipped. It does that. Then it creates a shipping label created event. And then from there, our sales can pick that event up to know, okay, kind of the whole cycle has been completed. We've invoiced our customer, we've billed them. The warehouse picked that up and it's allocated product. And now we've created our shipping label. We're good to go. Maybe sales at this point sends out an email to our customer or updates the status saying, yes, your order will be shipped now and it's fully processed. So a different way of handling this is with orchestration. So let me explain with the
right. So choreography is like these systems are just waiting there, waiting for messages to come in, and there's nobody really in charge. Nobody's really in charge. And sometimes certain systems that works great, and it needs more of this orchestration style where there's going to be one person that's saying, do this, do this, do this, do this, do this. And there'll be all these services waiting for those things to happen, but there'll be one central service that's like sending out, that's controlling the whole of the transaction. It's not just a free form flowing around. Sometimes it's better that way. Sometimes it's not. You really got to think about the use case and how your business works. And if you had people doing this stuff, like how would you actually put these things together? What makes sense? Because there's trade-offs, right, between one and the other, right?
exact same concept, is that sales is going to publish its orders placed event when we have an order that's placed. But rather than billing picking that up and all the different events just reacting to different events and publishing their own events, rather we're going to have a centralized place that's our orchestrator. And it understands to consume certain events, but also to send commands to other services.
As if like you're in an orchestra, and there's the head guy, and he can tell each people in the band to play their thing. They're all playing, but the orchestrator is like, he's like, do over here, you go more, you go louder, you go less, you go up, you go faster, you go slower, that's the whole idea. Is you got one guy, he's kind of in charge of all these things, and so he's orchestrating what goes where to who, how, and there's one person kind of in charge of all that.
So our orchestrator is going to pick up that order placed event, and what it's going to do now is it's going to send a bill order message to billing. Billing's going to process that message, and it's going to publish the order build event just like it did before. But now our orchestrator is the one consuming that. So it knows, okay, that's the next part of the process. Then it's going to send a create shipping label command that the warehouse is consuming. And warehouse, just as it did before, publishes the shipping label created event, which our orchestrator is picking up. So all the centralized logic is in a single spot within our orchestrator that lives in sales. The other somewhat advantage to this is because it's a centralized place, you can deal with compensating actions. So what's happened with billing, we've created
that compensating action. Okay, all that means is if something goes wrong, what do you got to do to undo that? So let's say the example of where you're going on a trip, and you have to reserve a car and reserve a hotel. Okay, let's say you call over and you get the first step, you got the car reservation done. Got it. But then you call a hotel, and all hotels are booked up. You can't get any rooms in the hotel that you have to be in. Well, then you have to cancel your trip, right? That's all. You have to call the rental place and undo the reservation so they don't charge your stuff for not showing up, right? So that's your compensating action. These technical terms are so goofy.
Created our invoice, and say when it actually came to time for warehouse to allocate products and do our shipping label created, it couldn't, but rather there was no product. So instead, the warehouse emitted the backordered event. Well, our orchestrator can pick up that event, part of the process, and knowing that there's a compensating action. Because we know we've actually billed our customer, we could then send a command back to billing saying refund this particular order. So orchestration just allows a centralized place to define what kind of all the business flow process is from events to commands. And choreography is just having all the different events just consume events and publish their own events. So the last thing we need to talk about is failures.
That's just two different styles. One person's in charge versus nobody's in charge. One can one is like there's like a single point of failure, right? With one service, if they fall, then nothing works, right? Whereas, but it's hard to track. It's easy to track who's doing what, right? But in the choreography style, where everyone's kind of dancing, right? Everyone's doing their own dance moves. There's nobody on the stage saying you got to do this, you got to. It's like everyone's doing their own choreography, right? That's the whole idea. Is that they're dancers, right? And that's so. But there's nobody in charge. But you can scale all these different elements. You can bring more people on the stage, less people on the stage. Like it's easy to scale each one of these elements because they're just responding to messages off cues, right? But you don't know exactly where each status is. It's really hard to query. What is this? What is the process that's in play? It's much more difficult to do that. But all these things scale independently and can fail and come up, and it's not a problem, right? So there's really no points of failure in that one. It's like everything's a point of failure. Like there's no individual point of failure versus the orchestration style. That's the big thing. That's the idea.
So there's different patterns and different concepts you can use here. The first I'll talk about is just retries and immediate retries. Let's say we have a message broker and a consumer, and we are consuming a message, and we need to talk to some.
So this transient means like sometimes things fail on these networks. Like sometimes machines go down, sometimes networks go down, sometimes power goes out, sometimes disks go bad, memory goes bad. We're dealing with machines. So these transient failures, like how do you deal with them? Well, sometimes it's just there's a blockage somewhere, something just messed up temporarily. These things are very complicated. So you can get these cascading failures. Sometimes you just need to try again a little bit later. That's all this is about.
Other service. It could be a database, an external service, whatever.
Maybe the guy's out to lunch, right?
The case may be. But when we're processing that message, we need to do that. We try to call it. It's unavailable or something's timing out. It's just not working. Well, one of the things we can do is just immediately retry. If it's a transient issue, maybe our next call will actually work and everything's good. We can act back to the message broker to tell it, okay, we processed our message. The other thing we can do is an exponential back off. So if we...
Exponential back off. So instead of calling every minute, hey, are you there? Hey, are you there? Hey, are you there? Hey, are you there? You call, every minute, every 2 minutes, every 5 minutes, every 20 minutes, every 30 minutes, every other day, whatever the thing is right for you. It's like, could it be a day between, is it okay to wait a day or two? When does it stop? Like it's all business role specific. It's all what business are you doing? But the thing is, maybe you don't knock on it right away. Maybe you do it slower. That's the whole big exponential back off. That's all this is. I could not believe there's just so much jargon, but here we go.
Consume our message, and we need to reach out to that external service and it's unavailable. Rather than immediately retrying, what we can do is wait a period of time, try to make the call again. If it still fails, wait even longer and then call again. If that still does not work, we just keep waiting, backing off, and then retrying again to see if our external service becomes online again. What happens if that service is unavailable for an extended period of time? We don't want to just continuously retry or have a never-ending exponential backoff. Rather, what we can do...
The dead letter. I love it how they mix all these metaphors together. You got orchestras over here, you got dancers over here, you got post offices over here, and it's all like just things people have terms have used in like books and at conferences, and it's got into the vernacular, and now everyone just uses it for this one thing. So instead of like, okay, the failure pile, the failure, the junk trail, like the missed pile, they call it the dead letter. All right, they call it dead letter. But it's just like anytime a message can't get through, where can we put it? Do we know that things aren't going so good? And this, what happens if this service fails? Like, you really don't want this service to fail if you have mission critical stuff, right? You want to know that that stuff has to stay up all the time. So maybe that's when you use an S3 bucket. That's when you use one of these cloud services, when you have to be absolutely critical for your use case. Make sure there's somebody else who's managing that infrastructure. You can use it. But if it's not that critical, you can still do it on-prem with your own dead letter in your own servers on-prem. Why not?
Is have a dead letter queue. So this means that processing our message, we're trying to use that external service, it's unavailable, we have our exponential backoff, but at some point we just want to give up and we want to move that message to a dead letter queue. So we can take it off our main message broker's queue, move
it. Doesn't even have to be a queue, it can just be a database, right? Doesn't have to be a queue, but that's what they call it, dead letter queue. Okay.
To a separate queue that we can deal with separately. That way we can process other messages that are coming in that we need to consume, but not get hung up by some message that just we can't process at the moment. So we can move it to a dead letter queue and deal with it separately. One of the primary benefits of using a messaging library is it applies all these patterns. It has implementations and ways of dealing with all these things. So things like the outbox pattern, item home consumers or an inbox, having an orchestrator.
Well, those could all be set up as databases. And I love Redis, man. It does publishing, publish, subscribe. It does so much stuff, man. It does all these different things, and it does it in a very simple way that's really easy to port. You can run it on-prem. You can use their managed service. It's well established. It's very fast, so you don't have to go to scaling with splitting up your modular monolith into a bunch of different services. By using Redis, you don't even have to do that. You may not even have to do that. Just add more RAM. Add a gig of RAM. Add 2 gigs. Add 100 gigs. Add a terabyte. Why not? If you can get away from using microservices with all the monitoring and all the stuff, it's just crazy how much stuff can go wrong. Just figure out what goes where and what's up, what's down, what's failing, what's out of memory. I mean, it's just 1,000 moving little parts. You got to have a team, right? When you're doing microservices, or even when you start to split off services, you're probably going to have a team. But we're trying to avoid that. We're trying to avoid that as long as we can until the thing is our MicroMonopoly is taken over the zone that we've established. Until that happens, we're just trying to avoid it. So let's use Redis.
Or just generally event choreography. Having things like retries, dead letter queues, because those aren't necessarily built into the message broker that you're using. Oftentimes, the messaging library are really what facilitates having all these fault tolerance capabilities like circuit breakers, retries, exponential backoffs.
But they're not that difficult, and KTOR has a bunch of that stuff built in, and it's actually not that difficult. It just really depends on your use case. And the way KTOR is set up with coroutines, writing these things is not hard. You don't have to have a library. You used to have a library. You really need to have a library. I mean, you can do these things on your own.
So again, depending on what platform you're using, I highly, highly recommend looking into a messaging library, because all these patterns generally, or some of them, depending on the library you're using, will have implementations and ways to deal with all these concepts. So all these different topics, patterns, concepts.
This is why KRES is what I'm recommending for Kotlin's, for what's good. Here we go. This is one. Yeah. So that's what I'm saying is oh man, I'm off in the weeds here. Where am I? Okay. All right. So yeah, go give him a like and subscribe. He does really great work, and these are stuff that took me a while to figure out because the jargon is so deep. But you know, I'll be your translator. All right, give me like a subscribe. I'll talk to you later.